Okay, in this class we're going to look at solving second order differential equations using a v substitution, and we're just going to look at a second example. Before I do, I just want to look, kind of go back. Suppose before I do this problem, I want to find the antiderivative of 1 over 1 minus t. Okay, how can I do that? Maybe it's a standard integral, I should say, with respect to t. One thing I could do is I could use u substitution. So a quick reminder of u substitution is if I make u equal to 1 minus t, well then du dt would equal to negative 1. So du would equal to negative 1 times dt. So negative 1 du would equal to dt. Something worth remembering. Negative 1 times du is equal to dt. So in this case, this is using u substitution. We went through this in class before the break. So what I'd be saying is I'd be taking the antiderivative. I'm going to look at my substitution. It's 1 over 1 minus t, which we're saying is u. dt we're saying is negative du, so du, but I'm going to factor out that negative 1. And so what we get is the negative of the natural log of the absolute value of u plus c. So the negative of the natural log of whatever the absolute value of whatever u was. Well, u was 1 minus t plus c. So that's something worth remembering, because that little antiderivative is going to crop up in my solution to the next problem. Okay, so with that in mind, go through it quick, make sure you're up to date on your u substitution, and make sure you can find the antiderivative of this thing. Okay, so with that in mind, I'm going to try to solve this equation. It says solve d2s dt squared is equal to the square of ds dt, given that s is 0 and ds dt is 1 when t is 0. So we said anytime we have the second derivative as a function of the first derivative, we're going to use a v substitution. And I'm going to take a derivative with respect to t on both sides. On the left, that's dv dt. On the right, taking the derivative of the first derivative will give me the second derivative. And here's my substitutions, right? So v is ds dt, so we can substitute that in there for that value. Also, by the way, we can substitute it in over here for this value. And secondly, d2s dt squared, well, we're going to call that dv dt at this stage, and that's going to substitute in there. So using those substitutions, I'm going to say, therefore, d2s dt squared, we're saying now, is dv dt is equal to the square of ds dt. Well, that's going to be v squared. So dv dt is equal to v squared. This is the beauty of this type of substitution, of this using a v substitution. Notice I'm not saying a u substitution. This is a v substitution. So it allows me to change a second order differential equation for a first order differential equation, and we looked at solving these before. So our goal is to separate the variables. Can I get the v's on one side with the v differential and the t's on the other side with the t differential? And I do that by dividing on both sides by v squared. On the left, I'm going to get 1 over v squared. But remember that 1 over v squared can be written as v to the power of negative 2. So I'm going to use that here. Dividing on both sides by v squared on the left will give me a v to the power of negative 2 dv, and dividing on both sides by dt will give me a dt over here on the right. So we've separated, and now we integrate. I'm going to take the antiderivative of v to the negative 2 with respect to v, take the antiderivative of 1 with respect to t, and solving this. So on the left, add 1 to the old exponent, gives me v to the power of negative 1. Divide by the new exponent, that's negative 1. is equal to, on the right, the antiderivative of 1 with respect to t is t, and plus the constant of integration. Solving here, v to the power of negative 1, remember, v to the power of negative 1 just means 1 over v. And if I divide 1 over v by negative 1, I just get negative 1 over v. So on the left-hand side, I'm getting negative 1 over v, and that's equal to t plus c, the constant of integration. Okay? So negative 1 over v is equal to t plus c. Going back to my initial conditions, we're saying that v, notice, v is ds dt, so v is equal to 1 when t is equal to 0. So I'm going to use that condition here. I'm going to say, but v is equal to 1 when t is equal to 0. That's given at the start of the question. Remember, v is ds dt. Therefore, negative 1 over 1, well, that's just negative 1, is equal to t, which is 0, plus c, which is c. So we get c is equal to negative 1. So I'm going to go back and write in my particular solution here. Negative 1 over v is equal to t, subtract 1. And I have different options here. One thing I can do is maybe just take the antiderivative. Actually, no, I won't. What I'm going to do is solve for v here. So I'm going to take reciprocals on both sides, and I'm going to multiply on both sides by negative 1. Maybe I'll start by multiplying both sides by negative 1, giving me 1 over v is equal to 1 minus t. And now I'm going to take the reciprocal of each side of that equation. So v over 1 is going to equal to 1 over 1 minus t. I've just taken the reciprocals, flip the fraction on the left, flip the fraction on the right. Remember, of course, 1 minus t is just 1 minus t over 1. Okay, so I've solved for v in terms of t. Ultimately, though, the variables in the original equation were s and t. So what I'm trying to do is solve for s in terms of t, the variable on the top in terms of the variable on the bottom. Also remember that v is ds dt, so we're kind of going to use that substitution in reverse now. We're going to now substitute ds dt in for v at this stage. So I'm going to say, therefore, ds dt is equal to 1 over 1 minus t. I'm going to separate and then integrate. It's a separable first order differential equation. ds is equal to 1 over 1 minus t dt, and I'm going to take the antiderivative on both sides. So I'm going to take the antiderivative on one side, on both sides, just tidying up my sign there. So on the left hand side, that's just the antiderivative of 1 with respect to s, which is s. And on the right hand side, that's the antiderivative of 1 over 1 minus t. And if I go back to the work I did at the start, the antiderivative of 1 over 1 minus t is the negative of the natural log of the absolute value of 1 minus t plus c. So the negative of the natural log of the absolute value of 1 minus t plus c. So go back here. So what we're going to get on the left is s, and what we're getting on the right is the negative of the natural log of 1 minus t plus the new constant of integration. So that's my general solution. To find my particular solution, I've got to look at my initial conditions. So again, let me scroll up and just look back at my initial conditions here. S is 0 when t is 0, but s is equal to 0 when t is equal to 0. Therefore, substituting in 0 for s is equal to negative of the natural log of 1 minus t in here. Look at that 1 minus t. Well, 1 minus 0 is just 1, and the absolute value of 1 is just 1. So we get the negative of the natural log of 1 plus c. Solving there, c is the natural log of 1. Remember, the natural log of 1 is the exponent to which e is raised in order to get 1, so that's equal to 0. The natural log of 1 is 0. I'm finally ready to write my final answer here. Therefore, s, the variable s in this case, is equal to the negative of the natural log of the absolute value of 1 minus t plus 0, and that's my final answer in there. Okay, so that's just a second example using v substitution. We can use a v substitution when the second derivative is given in terms of the first derivative. We set v equal to the first derivative, which means dv dt will equal the second derivative. Substitute those things into your original equation. Solve that first order differential equation. Remember, your initial conditions here will help you find your particular solution. I'm trying to solve for s ultimately. Before I do that, I solve for v. Once you have v, kind of unsubstitute here. ds dt we said in our initial conditions was equal to v, and then we've got to be able to take the antiderivative of this thing. The antiderivative of 1 over 1 minus t we looked at the start of the class was the natural log of 1 minus t plus c. So you have two options here. You learn how to do the u substitution, or you can remember this kind of thing off by heart. Okay, practice, practice, practice. And in our next class we'll be looking at a slightly different type of substitution to solve second order differential equations.